My project is handwriting recognition utilizing an artificial neural network. So the goal of this project is to be able to take in an image and read whatever is on that image. Now the image consists of 784 pixels, a 28 by 28 grid, and the outputs consist of digits between 0 and 9. So to keep this at a high level, the neural network by default contains 3 hidden layers with 12 neurons each, plus a bias term, which makes 13. This is easily configurable by just changing the constants in the program. Now, what I'd like to discuss here are the weights, which are the only things throughout this network that change. So the way training works is trying to adjust these weights to derive the values that you want from the output layer. So I'd like to discuss forward propagation, which is the way you make predictions. So these inputs are made up of 784 nodes plus a bias term. Now, each of these consists of a value between 0 and 255, with 255 being the color black, in between being gray. So those values adjusted with the weights go through an activation function, and I'm not going to get into that here, but basically all this data propagates and yields values in the output layer. Now those values range between 0 and 1, and whatever value is the highest is the prediction that that's the output, that's the prediction. So our goal is to train this network to have the lowest scores on the non-answers and then the highest score on the answer. So another thing I'd like to talk about is backward propagation, which is where the data propagates backwards. So it starts at the output layer and goes back. That is what training consists of. So again, predicting goes forward. Training goes backward as well. So that's where you get your output, you test your error, and you adjust the weights to reflect that error and to limit that error. So let's go over to the program now. So we'll start with the train, which this is going to initialize a new weights file, which is going to have randomized weights. It will then train it to a certain number. That number would normally be 60,000, which does the amount of data, the amount of images that's provided in the training data. I will do 10 instead, just for this demonstration. So as you see, a file is created. Now that file will be trained upon and updated. So each of these represents a full process of forward propagation and backward propagation on a given image. Each one is a different image. So here we've trained upon 10 images. Now, if you open the weights file, you'll see that these are basically the connections. So this is input 0 going to hidden layer 1, node 1. And then this is the weight for that connection. Now, this is all broken down by layer. So the white space represents a new layer. The reason this is so big is because there's 765 neurons in the input layer, each one going to a neuron in the hidden layer. So that's 765 times 13. That's why you'll see here, this is hidden layer 1 to 2, hidden layer 2 to 3, hidden layer 3 to 0, or to output. That's why these are so much smaller. But once the data is trained upon, it does not need to be trained upon again. It will be able to make predictions itself. So here's just a quick visualization of the data. In the future, I'd like to put this in a GUI, but I've been having some trouble with the back propagation. I have the data flow working fine. Just the mathematics portion of it, I haven't been able to figure out yet. So there's still some work I need to do on the back propagation side. That's why you'll see that the number it produces is incorrect. But yeah, so this is a visualization of the image, which is obviously a 7. And this is the prediction that the neural network made. Now, again, this is non-trained, but like I said, I've had some trouble with the backpropagation. So overall, I've been able to get the data flow. Forward propagation works fine. Backpropagation works fine as well, just the math portion of it. I am not properly adjusting the weights, which is something I will continue to work on.